All right, have another example. Fibonacci sequence. Fibonacci sequence is what you're seeing right here. How do you generate them? Well, pretty simple. Start with two ones. They're separated by commas because every single one in this list here is enumerated, meaning there's an index for each one in this method. So let me go ahead and show you that. The first one is in position 0. Computers always start at 0. This is in position 1. This is in position 2, 3, 4, 5, 6, and so on. So what we have here is Fibonacci. Fibonacci also done with a long, just because a long is 8 bytes, gives us more space. We can definitely overflow this stack, although we won't in this example. So what I'm going to do here is just look at how the Fibonacci sequence is being called here, how it calls itself, and then we look at the stack. We're going to run a few examples just to verify the stack. That's all we'll do. So here we go. It takes in a long, just like the sum before, it returns a long. Okay, base case. If we get a 0 or a 1, return a 1. How so? Because this guy is in position 0, this guy is in position 1, and that will be my base case, two of them. If it's a 0, it's a 1. If it's a 1, it's a 1. So that takes care of the base case. Recursion, tail, last step. This calls Fibonacci. It says, when you push onto the stack, push the sum of Fibonacci n-1 and Fibonacci n-2. Every time this gets called, there are two pushes. Let's get that clear. Two. So how are we going to draw this stack? We're going to consider this the left push and this the right push. So I'm going to go to the right and then I'm going to go to the left and put the plus in the middle. I have a stack down here. It looks all crazy, but I'll walk through it just to see how everything works. Follow along. Okay, the example I'm going to do right now is Fibonacci 5. Okay, just like I did with sum 5. So here we go. I'm putting an F for Fibonacci. I'm not going to write the whole word Fibonacci. And again, this is kind of spread out because you need to draw your tree spread out so that everything fits. And I'll show you how the arrows work in terms of where I'm pushing. So here we go. Fibonacci 5 gets called. 5 comes in. Is a 5 a 0 or is a 5 a 1? No. Both cases, no. This is false. So push onto the stack. Fibonacci 5 minus 1, which is 4. Fibonacci 5 minus 2, which is 3. All right, let me show you that step right beneath. Again, remember, this is upside down. Fibonacci 5 is actually on the bottom. This is the next guy on top. So 4 plus 3 came from here. Now, that's the left push, which is this one. And this one is the right push, which is this one. How do I get that? Well, 5 minus 2 is 3. And 5 minus 1 is 4. So on the left, we have a minus 1, and on the right, we have a minus 2. So here we go. 4 comes back. You have to treat each one separately. Now, we have two pushes. 4 comes back. Is it a 0 or 1? No. Push onto the stack for the 4. 4 minus 1 and 4 minus 2. That will be 3 and 2 right beneath here. So we kind of have this kind of weird thing going on here because this is the left push from the first, but this would be F2 in this case would be the left-right push. See, arrows coming from here, that first push, then go here. This F3 would be the left push. So F3 comes back and it says, is it a 1, is it a 0? No, both false. Push onto the stack, the subtraction. On the left, take 1 off. On the right, take 2 off. So on the left, we'll have a 2. Take 1 off from 3. On the right, it'll be a 1 because we take 2 off from 3. Base case. 1 and 0 base cases. So nothing pushes here. But this, still going, comes back. F2, not a 0, not a 1. Push onto the stack. F1 plus F0. Again, take 1 off from 2. We get a 1. Take 2 off. We get a 0. Base case, the left portion is finished. The same thing happens on the right. I hope you realize there's some kind of symmetry here. You see F3 is the same thing as F3 here. Remember, recursion, a simpler version of itself. So F3 here gives me F3 over here. It looks just the same, right? So watch carefully. You'll see the same thing here over here. So yes, when 3 comes back, it's not a 0, it's not a 1. Push onto the stack. On the left, take 1 off. On the right, take 2 off. 1 off, 2 off. Base case, 2 comes back. Not a 0, not a 1. On the left, take 1. On the right, take 2. Base case. Whew, that's a lot. Now, because there are two pushes. So whenever there are two pushes, there needs to be the first one is going to be left and the second one is going to be right all the time. Do not think in your mind there are going to be 3 pushes. That's crazy. Okay? Is at most 2. All right, popping off the stack. This is a 1. This is a 1. We said that right here. 1 plus 1 is 2. So that means F2 is 2. If you're doing this on the AP exam, when you find symmetry, just substitute. So for example, F2 is 2. We know that. So that means this is 2. Let that one sink in. I did it over here. Substitution is going to win at this point. That's a 2. F3. How do I get that? Well, 1 is a 1. That's what he said up here. Add it to 2 to get a 3. So F3 is 3. So you know what I just did? I figured out that and that. I don't need to do this again. I already did it. Look for symmetry. So this is 2 and this is 3. When I add them together, I'll get a 5. So F4 is 5. And then 5 plus 3 will get me what that is, 8. But let's check this out. We said that when we push 5, and the first call is 5, that's the first push, the answer should be 8. So 0, 1, 2, 3, 4, 5. Yes, 8 is in position 5. Let's run it. 8. No surprises there. Let's check an easier one though. What about F3, right? Just F3. Like if I do sum, find me not the sum, but the Fibonacci 3. The guy is in the 3 spot. It'll be 0, 1, 2, 3. Should be a 3. We already checked it out, right? 0 plus 0 would get us a 1 and a 1. These two added up to get me a 2. F2 is a 2. Add on a 1, get a 3. Let's check that out. Swap out the 5 with a 3. And let's see if our Fibonacci is working. It's a 3. Working perfectly. All right. Yes, we can overflow the stack. But in this case, we are not going to overflow the stack. As a matter of fact, don't expect the stack to overflow a lot on the AP exam. I'm just saying that sometimes they could do that. They could show a base case that doesn't make sense or is not reachable. But for most of our examples, the base case is going to be reachable. We're going to use reasonable numbers such that we can get an actual solution. That's it. Fibonacci.